Hello, in this movie I would like to show you the development status of the PIM passive intermodulation calculator and Windows RF calculator in version 2400, which is planned to be released in the first quarter of 2024, the coming new year. Right, so let's have a look what is happening with that calculator, how it is working, and what kind of possibilities you have. Let me first change the way the mouse is showing itself. Here you see the mouse; it's a little bit better to view. So let's go to General RF, and here you see the PIM calculator. So let's close this window again, and if you start the RF uh, in the RF section, general RF section, the PIM calculator. After starting the PIM calculator, it first opens the channels, the frequency channels settings form. Now, in its maximum, there is a availability of total 16 channels on the TX side, which is the transmitter side, and in total 16 channels are available as well on the actually the receive or PIM analysis side. Um, what kind of settings are possible? So you can set, for example, for channel 0, you can switch the channel on or off. So you do that with the checkbox here. At the moment, of course, it's switched on. Center frequency, 800 megahertz, which is the transmit frequency. And to simulate modulation, because if you just do the PIM analysis with static frequency for all these channels, then of course the result of the intermodulation products will always be on the same frequency. So each channel can be more or less say modulated with what we call a random walk. And so this frequency here, 800 megahertz, has a variation possible between 800 megahertz plus or minus 2 megahertz. So the frequency will vary between 802 as maximum and 798 as minimum. Now this is the analysis section. So you want to have an insight in certain frequencies where you have, let's say, you receive channels of your system. What is happening, let's say, distortion-wise, with all these in all these frequency bands? So what you can program here is switch on or off the channel. Again, we have also 16 channels here. You can switch it on or off. Define the center frequency of the channel under investigation and select a bandwidth. So this is more or less the operational bandwidth of your system. And there's two selections possible. We have a 9 megahertz or a 27 megahertz span. So just compare it with the spectrum analyzer, center frequency, and this is the span. Let's say setting frequencies, let's say we do that in a later version of the explanation software. This is just showing the current capabilities of the software. So click close and confirm. And then in the analyzer main screen, let's close this window first. You have this box here with your 16 transmit channels. So from channel 0 to channel 15. This is of course the maximum capability. How we are going to define the number of channels with respect to possibilities depending on the type of options you have in the software is still to be determined. It looks like in a free version, let's say in the low cost version, we will have one channel available, and then in the paid version, 8, 12 or 16 channels in total. So this is the main frequency section here. So here you see the total spectrum. Let's just run one sweep at this frequency, for example. This is a manual sweep. So what you see here is the frequency range from 0 to roughly 8.5 gigahertz. You see, this is quite a large frequency band. We need that because in the PIM analysis, we don't want to have a lot of folding of distortion signals around this Nyquist frequency. So the sampling rate is about 17 gigahertz here, and the operational bandwidth 8.5. And here you see the channels we have defined. So let's say this is about the 250 megahertz are here, 800 here, 1 gigahertz here. And you can zoom in this spectrum, and what becomes clear if we go to, for example, these here, you see that the resolution is not really nice. It's 500 kilohertz, 524 kilohertz resolution bandwidth. So just unzoom everything completely. In the low range here, between 250 and 254, we have in total 5 channels. Let's zoom in on that 250 megahertz here. And what becomes clear because of that resolution and that top frequency span, you see here that all these frequencies, you cannot really discriminate on those frequencies. It's very difficult. Now, if we select, for example, the analysis channel 253 megahertz in a 9 megahertz span, just click on it, then calculations are redone. So we get a resweep of the top spectrum, and then a zoomed version here below of the 253 megahertz. Right. So let's run this software automatically. Let's just show you how this is working. You click on the checkbox here, run the full PIM scan, and it's scanning all these channels. Let's say with respect to the zoom function here to show what is going on in all these receive channels here. So this is the main scan. Initially, when you click this one and the first channel is calculated, a sweep is made with all these signals and an analysis between 0 and 8.5 megahertz, giving you all these spectral lines. That is just one sweep. After that sweep is done, each frequency is going to be analyzed here in a zoom function. So what you see here that all these zooms are passing by and show you the result of the zoomed analysis. Now, it becomes clear that the analysis sweep in zoom mode here is roughly about 2.3 seconds. And the reason for that, let me show you the detector form. Click on the detector form. This is actually the output of all the analysis. And it becomes clear. Here you can see in total 16 channels. Channel 0 to 4, 0 to 3, 4 to 7, 8 to 11, 12 to 15. And at the moment in the current version, what you see here is the last sweep. Now, if you go back to channel 1 again, you can see here the result. This result is shown here. And watch this frequency here. Because of the random walk, they change. There they are. And now it's updated on the last version of the sweep. So this is the last version. We are writing software now to have in each graph three additional sweep informations. This is the last sweep, the green one. Additionally, we will add the maximum hold version. So if you have all these variations in the spectrum, the max hold line will show you the maximum level that ever happened in, let's say, all the sweeps that have been performed. What is happening in this portion of the spectrum with respect in the max hold version? Next to that, also an average version is shown, so there you can see the average power depending on a total of 10 sweeps. So there is a 10 sweep average function foreseen, and in each graph a different color will be available for, let's say, these different sets of information. The little bit darkish green line here is because the bandwidth, there's more information here. The bandwidth here is 27 megahertz. So you can see here just below 1900 up to about 1925, you see that is 27 megahertz of spectrum bandwidth. If you go to the 1 gigahertz channel, this is channel number 6, you see the center frequency is 1000 megahertz, and it's, let's say, plus minus 4.5, total width is 9 megahertz, to show you the spectral information about that frequency. Question will be, of course, why do you have all these strong signals here? Well, for this demonstration, we have programmed a number of signals falling in the analysis bands. Of course, if you do your PIM analysis, you will only have here your transmit frequencies or your downlink frequencies from your base station to the mobile. And here your RX frequencies will be programmed. So these are the receive frequencies where you are listening to the mobile and where your passive intermodulation products can fall. So this is a quick update on the status of the PIM analyzer in WinRF Coke version 2400. Release date somewhere Q1 2024, and we hope to get this part of the development finished in the month of December 2023, so that it is available for you guys in the next available version. So thanks for your attention, and let's say hope to get this soon on the market. Thanks for the attention. Bye bye.